Alright, in this video I'm going to talk about ionic equations and a better way to represent double displacement reactions. So imagine we have some sort of ionic equation like sodium iodide reacting with lead 4 nitrate, and those things would have been aqueous in solution when this reaction started, and they are going to go to form sodium nitrate, which will be aqueous. There's 3 of them, and lead iodide. Is there 3 or 4? Hold on, I gotta be careful here. Just slow down a second. Lead iodide. Lead 4 iodide. And that, here's the important thing, that becomes a solid. So that is what makes this a meaningful change. Now I've got 4 iodides here, so I need 4 iodides there and 4 sodiums there, so I'm going to need 4 sodiums there. Now we're properly balanced. Okay, so there's a reaction. That's what we're working with. The problem with this way of representing this reaction is it implies that sodium and nitrate have undergone a meaningful change. But the truth is, those 2 ions were aqueous in solution before the reaction, and they're aqueous in solution after the reaction. So in a real sense, they actually haven't been involved in the reaction in any way. They have maybe spectated the reaction, and so we call them spectator ions. This is a little much, but let's write this entire reaction out from the perspective of what's really going on, and by that I mean as the individual ions that are dissolved in this solution. So before the reaction, we would have had 4 sodiums, 4 iodines, 1 lead 4, and 4 nitrates. And then after the reaction, I would have 4 sodiums, 4 nitrates, and the lead and the iodine would have clumped together to form a solid or crystallized. So what we notice here is that these 4 dissolved sodium ions exist before and after the reaction unchanged. So they don't actually do anything in the reaction. They spectate the reaction. Similarly, these 4 nitrate and these 4 nitrate just sit there. They don't actually do anything. So, I mean, they're not really watching their atoms, but we can imagine them as just watching what's going on, and so we call them spectator ions. Alternatively, the meaningful reaction that happens here is that lead lead 4 is combining or crystallizing with our 4 negative iodine ions, to make lead 4 iodide. That's what's actually happening in the solution. All the rest of these ions are just there to provide neutral solutions. They're not actually involved in the reaction in a meaningful way. That's why this is a better representation of the real reaction that's happening here. We call this the net ionic equation because just like a net profit or something like that, it just simplifies the reaction down to a simpler, or to the meaningful change that happens. One more time, our old way of writing double displacement reaction implies that chemical compounds form that don't really form. It includes a bunch of ions that we call spectator ions that don't really participate in the reaction. They're dissolved before, they're dissolved after, and so no meaningful change takes place. So if we boil that down to the net ionic equation, we can focus on the actual change that occurs in the solution.